All right, welcome back to the class. Let's continue again with reactions of ions in solutions. We'll look at introduction, electrochemical reactions, pathway of general electrode reactions, and then we conclude. Now, an electrode reaction or electrochemical reaction refers to the net oxidation or reduction process that takes place at the electrode. Now, of course, we have our anode, we have our cathode. This reaction may take place in a single electron transfer step or as a succession of two or more steps. So the oxidation or reduction reaction that takes place can be a single step or different steps in succession. The substance that receive and lose electrons are called electroactive species. Two chemical reactions occur in the cell, one at each electrode, and these are referred to as half reactions. The reaction as the anode, I mentioned cathode. The reaction at the anode is an oxidation reaction that releases electrons. Those electrons then flow through the wire to the cathode, where reduction reaction takes place. Therefore, electron reactions can be classified into two groups. One, in which an electron transfer takes place across the electrode interface. Just such as this example, we have ferric to ferrous redox reaction. This is ion 3. When it takes up electron, it becomes ion 2. And the second type, in which an ion transfer takes place across electrode interface, such as ion dissolution or deposition. Therefore, there are two types of current flow in electrochemical cell. Remember, we said two types of electrode reactions. So we have two types of current flow. One is called Faradaic and the other one is non-Faradaic. And the Faradaic is a charge transferred across the electrified interface as a result of an electrochemical reaction, which is governed by this equation. Remember, we have our Q as a quantity of charge, N is the number of electrons, F is the Faraday, N is the moles electrolyzed. And then we have the non-Faradaic charge associated with movement of electrolyte ions, reorientation of solvent dipoles. Remember, we said that if you have something like zinc sulfate, when it ionizes, then there will be an interchange or reorientation of the solvent dipoles, that is solvent ions, adsorption or desorption, and so on at the electrode-electrolyte interface. For example, if you look at the Daniell cell, that is a voltaic cell, the simple example of voltaic cell, we said that copper is deposited on the copper electrode. So we can see adsorption or desorption. Desorption also, zinc is dissolved or dissolved from the zinc electrode. And this is the background current in voltammetry measurements. The electrode reaction kinetics are affected by the electrode surface cleanliness, surface microstructure, and surface chemistry. So the surface of the electrode is very, very important. Is it very rough? Is it smooth? And of course, surface reactions that can take place. Magnitude of the potential controls the direction and rate of charge transfer. Kinetically fast electrons have significant Faraday current flow near E0 values, while sluggish reactions have little current flow except at large overpotentials. As a potential is moved negative, the species that will be reduced first, assuming all are rapid, is the oxidant, that is the acceptor, in the couple with the least negative standard electrode potential. pathway of a general electrode reaction. We'll use a diagram to explain all these things we'll write in here. We'll have mass transfer of the reactant product to and away from electrode surface, electron transfer at the interface, preceding a follow-up chemical reaction, surface processes, the absorption and desorption we have said. Of course, the modes of mass transfer as follows. It can be migration, it can be diffusion, it can be convection. Now, if you look at this diagram, look at the electrode and look at the electrode surface, look at the electrode surface region. So we have divided into two. Don't mind this distance, we just created this distance for you to understand. It's very close to the electrode surface. Now this is a bulk solution. So look at what we have said that is happening. We have electron transfer, absorption, desorption, chemical reactions, and then we have mass transfer from the surface of the electrode to the bulk of the solution. Of course, all these things are kind of equilibrium reaction. It goes this way and it can also go that way. So the same thing happens here. For oxidation, this is what is happening, and of course for reduction, this is what is also happening. Yeah, thank you very much. We try as much as possible to make all these videos very short, so that you can always pause, reason what is there, and see if you can clearly understand what you are saying. Thank you very much, and hope to see you in the next class.